Before troubleshooting, verify that the exact dryer, booster fan, duct design, and local rules permit this system. A booster is not a generic cure for an overlong, restricted, leaking, or incorrectly built exhaust. Record the dryer model, fan model, sensor type, installation location, and documented sequence. Treat poor exhaust as a fire warning. Long drying times, unusually hot laundry or room air, burning odor, repeated thermal trips, linter on joints, weak termination flow, scorch, smoke, or damaged ducting require stopping use. Do not keep cycling the dryer simply to make the booster trigger. Gas dryers add fuel gas and carbon monoxide risk. Gas odor, a carbon monoxide alarm, soot, smoke, suspected combustion spillage, or abnormal heat ends troubleshooting. Follow emergency guidance and obtain qualified fuel gas and exhaust evaluation. A booster cannot make a leaking or blocked gas dryer exhaust safe. Identify the actual sensing architecture. The controller may use a diaphragm pressure switch, airflow or pressure sensor, current sensing relay, temperature sensor, or integrated electronics. Some systems intentionally delay startup or shutdown. Never assume that every tube is a pressure switch or that one timing value fits all products. The dryer and booster commonly have separate electrical supplies. A stopped fan, dryer control at off, timer expiration, or quiet controller does not prove isolation. Automatic controls may start the fan or keep it running after the dryer stops. Covered work requires control of both systems and all stored energy. The sensor is not tested by bypassing it. Never jumper switch contacts, force a relay, apply line voltage to a control lead, backprobe exposed mains, directly energize the motor, or alter a sealed set point. These actions can hide a blocked duct, create continuous operation, and destroy diagnostic evidence. Do not blow or suck on sensing tubing by mouth. Lint, condensate, and contamination may be present, and uncontrolled pressure can damage the diaphragm. In the verified isolated state, inspect the port and tube only as the exact manual directs. Do not enlarge an orifice, shorten tubing arbitrarily, or add unapproved tees. Diagnose the complete airflow path before blaming the switch. Check the manufacturer accessible lint filter in transition, rigid duct, elbows, crushed or kinked sections, leaking joints, booster housing and cleanout, exterior termination, and damper. Restriction may create an abnormal signal, while an upstream leak may prevent triggering. Duct materials and fasteners matter. Plastic or vinyl foil, unsuitable transition duct, screws projecting into the airstream, lint catching screens, household tape, and exhaust into an attic or crawlspace may violate instructions or code and increase lint accumulation. Correct the system design rather than tuning around it. Cleaning must contain lint and protect the duct. Do not run an open duct to blow hot moist lint indoors or into concealed spaces. Compressed air, leaf blowers, and aggressive rotating brushes are not universal methods. They can tear or disconnect duct, damage dampers, drive debris into the motor, and aerosolize combustible dust. Replacement components require exact system compatibility. Match sensor type, switching logic, electrical rating, pressure range, time delay, tubing and port, environmental limits, motor voltage, speed, direction, thermal protection, airflow and pressure range, connectors, and listing. Similar fit or voltage is not enough. Commission only after restoring cleanouts, covers, guards, grounds, tubing, duct joints, supports, and the exterior termination. With the complete system, verify the dryer call and documented start and stop delays, termination airflow, damper action, noise, vibration, leakage, and abnormal heat. Gas systems require qualified combustion verification where applicable.